Question 7 comes in 4 parts. In this first part, we're given that z is equal to 1 plus I and w is equal to square root 3 minus I, and we're asked to find z to the power of 10 in the form divided by w conjugate in the form a plus ib, leaving our answer in the exact form. So the important thing here to note is that if I'm going to calculate z to the power of 10, it's very difficult if I just expand out z as 1 plus I using my binomial theorem or something. It's going to take a very, very long time. And similarly, if I'm dividing, it's also going to take a long time. So what can I do to make my life a little bit easier? Well, instead of writing it in Cartesian form, I can write it in either trigonometric polar or exponential form. And I'm a big fan of the exponential form, so we're going to use that here now. So to do that, I need to firstly work out what is the modulus of z and what is the argument of z. So modulus of z isn't too bad. We just take the square root of the square of the real and imaginary part, so 1 squared plus 1 squared. That gives us square root 2. And what about the argument of z? Well, to work out the argument, it always is a good idea to take a quick look at the Argand diagram. And if you think about it, this is what it's going to look like, where this is 1, and this up here is also 1, or I, if you prefer. This is the real, this would be the imaginary, right? So, what does that mean? Well, that means I'm actually looking at a 1, 1, root 2 triangle. It means each of the angles in here is 45 degrees, or pi upon 4 radians. So that means that I can actually say that z is equal to square root 2 e to the I pi upon 4. This is exactly the same as saying z is equal to 1 plus 1 I. So, that's z. What about w? Well, we'll do the same thing. What is the modulus of w? It's going to be the square root of 3 squared plus 1 squared. And that's going to be square root of 3 plus 1, square root of 4, which is just 2. What about the argument of w? Well, again, we can draw out the Argand diagram. If you think about it, this is going to have real part root 3, imaginary part minus 1. So it's going to look something like this. But if you examine it, what is this? This is nothing more than a 1, 2. So this is our 1, this would be our 2, this would be our root 3 triangle. So in this circumstance, what do I know? I know that this is 60 degrees. So this is 30 degrees. So this will, in here, this angle in here would also be 30 degrees. But we're not interested in the angle, we're interested in the argument. So the argument's actually minus 30 degrees, or minus pi upon 6 radians. So that means that w is 2e to the I minus pi upon 6, or rather, and therefore, w conjugate is going to be 2e to the I pi upon 6. Just take the negative of the argument. So that's great. What does that tell us about z to the power of 10 over w conjugate? That means that this is square root 2 e to the I pi upon 4 to the power of 10 over 2e to the I pi upon 6. So what is this? Square root of 2 to the power of 10 is going to be 2 to the power of 5, e to the I, 10 pi upon 4, over 2 e to the I pi upon 6, right? So what's that going to be? It's just going to be 2 to the power of 4, e to the I, 10 pi over 4 is 5 pi over 2, minus pi upon 6. And what's that going to be? 5 pi over 2 is the same as 15 pi upon 6. That's going to be 14 pi upon 6. So I'm going to get myself, sorry. 2 to the power of 4, 16, e to the I, and this is 15 pi upon 6, minus pi upon 6, so 14 pi upon 6, or 7 pi upon 3. And actually we don't like that answer very much either, because it's outside our principal domain, so we remove 2 pi from it, 2 pi being, of course, 6 upon 3 pi, and so that gives us 16 e to the I pi upon 3. That's great. So how do we convert this? And remember, we're asked to give it in the form a plus ib. So what do? Well, now I'm going to go from this exponential form back into my trigonometric polar form, back into my Cartesian form. So I have 16e to the I pi upon 3. What's that going to be? Well, I know the modulus is 16, and then I just put cosine pi upon 3 plus I sine pi upon 3. And this is now my trigonometric polar form. But what do I know about cosine pi upon 3? And again, this is where knowing my 1, 2, root 3 triangles come in very handy. So this is my, oops, not quite drawn it right, but this is my 1, 2, square root 3 triangle, where this would be pi upon 3. So cosine of pi upon 3, so this would just be 16 times a half, right? Because cosine, opposite over hypotenuse, will be a half. Plus, and what's I sine pi over 3? That would be root 3 over 2. So I root 3 over 2. And so you can see here that our final answer is going to be 8 plus I times 8 root 3. And that's the answer to part A.